So hello and welcome back for another tutorial for the Arduino. So today is we're going to combine the LED and LDR and attach it to the Arduino. So the LDR will act as a sensor, and the sensor will control the LED, the brightness level. So if the environment goes dark, so the LED will on. So if the environment goes light or brighter, so it will turn off the LED. So the component that we're going to need is the breadboard, 10K resistor for the LDR, and 220 ohm for the LED. So we're going to combine this now. So first is the LED. So we're going to put it to digital pin 13 to the 220 resistor, then to the anode, then to the ground. So we'll create a ground, we'll put it here, change the color. The ground is here, put the ground there. So it's all connected now. So 13 pin to the resistor, then to the anode of the LED, then to the ground. So next is the photoresistor LDR. I'm going to connect here the LDR and here. So we need a power for the LDR. Next is put ground. And in order to get the data from the LDR, we're going to put an analog pin. So we're going to put it between the 10K resistor and the LDR. So here's the circuit. 5 volts going to the terminal pin of the LDR, then the other pin is between the resistor and the analog pin of the Arduino, then goes to the ground. So I think that's the circuit now. So it's time for the code. So I already have the code, so I'm just going to explain it again. And first line is we're going to create a variable, a sensor value. So for the sensor value that we're getting at the LDR. Next is the void setup function. So we pin mode the A0, which means the analog pin A0 of the LDR into input. So we're going to get data from the LDR to the Arduino. So next is pin mode 9. I'm going to change it to 13 for the LED and set the mode into output in order to make high and low later on. So next is the serial that begin 9600 baud rate to start the serial monitor again. So in the void loop function, we set the sensor value to the analog red A0. So the analog red A0 is the data from the LDR, so it becomes the sensor value. So if we try this, we're not going to display this yet. So if we run this, the data that we're going to get is 54 to 974, right? 54 to 974, 54 to 974. So next, so in LED, in digital, in LED in analog, so the only values that we can get is 0 to 255. But in here, the value that we can get is 54 to 974. Let me just 54 to 974. Set comment. So what we're going to do is we're going to map. So a map is a function. It will change the range that you wanted to change a value. So sensor value. So the sensor value which gets 54 to 974. We're going to change it to 0 to 255. So what we're going to do is this parameter. First parameter is the variable that we're going to change, or the value inside that we're going to change. So 54 to 974. Then next is the value of what are we going to change. So we're going to change it to 0 to 255. So it changed now to the value of 0 to 255. So we're going to try that and serial print the fade. Let's see. So we can see 54 and 0. So if we increase that, we get 55 and 974. So that's correct. We get the value from fade. Now is so the sensor value becomes the fade, which is 0 to 255. So we're going to analog write it. So the pin 9, which is the LED, then the fade. So it is going to fade if you increase the value of the resistor. Then we delay it to 100 microseconds. I think that's it. So we're going to try to run. Wait, oh, it's not 9, it's 13 pin. Fucking hell. It's backward 255 to 0. So sorry for the inconvenience. So this one is, if this one in the other side is dark and the other side is bright. So if it's dark, it's turned on. So if it goes to light, it will directly turning off. So in this side of the LDR is very sensitive, so it has a lot of value in here and small value in here. That's why it gets directly to turn off. So I think that is, and thank you for listening.